Good morning everybody. In the previous videos we have done about reflection of light at curved surfaces. Now we are going to get about refraction. Refraction means the bending of a light when it passes. Light means when it means light. The bending of light when light it passes from one medium to another medium. Okay, so that is definition. But why it passes? Okay, it passes because the speed is different in different media. So that is the reason you can write. Now coming to the next, generally lens means actually refracting media, means the media in which the light bends. Medium means the substance through which light passes. Okay, refraction means light bends, I say. So it means that from lens light will pass, like glass, water, air, etc. Light will pass, but it will bend. It won't go straight. Okay. So what is a spherical lenses means? These are the refracting substances. Lens means refracting substance. Okay, which are obtained from a sphere. Means, for example, if you take a transparent glass, means solid glass, not empty. Okay, not hollow. Like that. For example, you are cutting a part. Then what will happen? You will get a convex mirror. Convex lens, which is convex lens means the lens which is thicker in the middle and thinner at the edges. If you touch like this, like for example magnifying glass, if you see, okay, if you touch it physically, then what will happen? You notice that it is thin in the at the edges and thicker at the middle. Okay, and concave lens means you can say that the lenses means if you cut a part, for example somewhere here you will cut like this, and again you will cut like this, then you will get a part which is like concave, which is thinner in the middle and thicker at the edges. That is called concave lens. And when you go through lens, you will understand its terminology, terms related to lenses. What is optic center means? For example, if you take a convex lens, optic center means it is nothing but the center of the geometric center of the lens. And focal point means whenever a light ray parallel to principal axis where it travels, it will pass through a point on the principal axis. That point is called as principal focus. What is principal axis means? Generally the light ray which is passing from the center of curvature, center of the sphere of which the lens is a part. Means if you extend this surface, you will get a sphere, right? So what is that? See, we can say this is center of the sphere. So center is otherwise called from here to here in lenses. Generally, we don't use the symbol C. From O to focal length, F distance will be there. Means some small focal length. 0 to F is small focal length. Okay. So it will be double. It will be a little double. So that is the reason we say it as 2F. So 2 capital F, and really it will be from 0 to 2F. The distance is called as R, and R will be really 2 times of F, like that. Okay. So principal radius of curvature means it is the radius of the sphere of which spherical mirror is a part, you are saying. Focal length means the distance between the optic center and the focal point or principal focus is called as focal point. So these are two terms related to this lens you are learn. Then what we will do, we will go through the rules for convex and concave and image formation and sign convention, numericals we are doing. Right. So what I will do now, first of all, I will say the rules. What are the rules for convex and concave? See, generally any light ray which is coming parallel to the principal axis will pass through a point on the principal axis. That point is called as okay, focus. So from there, so this rule number 1 you have to take. Okay, second rule, what you do, okay, this is for convex, and concave you take like this. Okay, the light ray which is coming parallel to the principal axis, after okay, refraction will go like this, so you can take this point as F. Okay, and the any light ray which is opposite to the first one. See here, refracted light ray is going through F. Now, for example, incident light only is going through F, but after refraction, it will become parallel to the principal axis. This is called as whatever second rule. So this you can take, or otherwise here, incident light ray only is going to pass through F, for example, like this, but actually the light ray will bend like this and it will come like this. So this is rule number 2. And third one is very easy rule. The light ray which is passing through O like this, so it will travel undeviated. Okay, so okay, so it will travel without deviation. So that light ray you can take. Okay, like this will go. Okay, so here also for third case you can take like this. The light ray which is coming parallel to the principal which is passing from optic center, it will travel and leave it. So these three libraries you have to take. Now coming to the this image formation by convex lens. See, opposite to mirrors, in mirrors concave will have 6 cases generally, but here in convex will have convex lens will have 6 cases and concave lens will have only 2 cases. Understood? So there in mirror, concave will have 6 cases mirror, and convex mirror will have only 2 cases. So it is like opposite. Now we'll see about image formation. See, when generally you take the object from close to far. For example, closest to far. Closest to far means first case you will get this one, magnifying lens case. See, generally to magnify any image, generally okay, we can see, for example, so generally we will take magnifying glass. If you want to see any small parts like that, we will use magnifying lens and see. No? So for example, like the people who are working in narcotics department, like to see the fingerprints, like that, they use this magnifying lens. Even biology, who the students of who are reading biology, so those botany and zoology, what they do to see the smaller parts of a leaf or otherwise any insect, etc., they use generally this magnifying lens. Okay, so now magnifying lens, many uses are there. So what we are going to learn is regarding image formation by convex lens, first case. Okay, that is when the object is between F and O. Okay, image formation by convex lens. See, okay, so what we do, we need a tall image. So we'll try to draw this one. Case 1 will take. Okay, so when image, when object is between, also you can write, is between O and F. O means optic center and F means focal point. For example, like this we do. This is O, this is F. So now take this. Okay. Now the light ray will go like this. Okay. Okay, like this. And another light ray will go like this. For example, this is only O, for example. Now light ray, this light ray will go like this. Okay, but for a person who is seeing from this side, for example, you are reading small alphabets which are very small size like AB. So for that person, it will appear as if the light ray is coming from here. Okay, the light ray is coming from here. For example, you take like this. Is it straight or not? Okay, I think it is coming from here. They are meeting here, I think. Okay, so this here. Okay, slide a little. Okay, so to certain extent, I tried my best. So now, so you see this. This is A dash B dash is image, and AB is object. So for a person, see the light ray before refraction, after refraction. See, before refraction and after refraction. So for our eye, it will appear as if it is here. So means small object, for example, you are seeing a small alphabet, it will appear bigger in size. So this is very important case. It will come in exam, number of times it is asked. But only thing is you have to take care here that the light ray will go a little straight only like this. It should appear as if it is going straight. Okay, somewhat like this. Then it will be clear. Okay, so then you will get full marks. Okay, and labeling parts. Okay, labeling parts is very important. When you write here, you have to write the things. What are 3 points you have to write? Position of image. What is the position of image? Is the image is formed on the same side of the object. Okay, so you have to write like this. Image is formed on the same side of object. You have to write. Or even behind the object also is fine. Done. Next one. What your nature of images, anyhow you can see it is virtual and erect, and third case you write like this. Size of course, full name is size of image. Here also of image you write. Okay, and here also you write size of image you write. Okay, so what is the size? Anyhow it is magnified, or you can say enlarged. So these are the cases. So in this way you write for each, you write the cases. Okay, so very important. Now we'll come to we'll go through remaining 5 cases. Okay. Anyhow, I think one more case I think I can draw here. I will draw one more case. Okay. Say for example case 2 you take. Okay, what is case 2? For example, the object is kept at f. Exactly at f you are keeping. Then what will happen? If you keep the object at f, the light rays which are coming like this will go like this and it will go. So these are parallel light rays, they never meet actually. So that is the reason what you have to do. You have to say that the light rays, okay, means the light rays generally there are no two parallel exactly. So what scientists claim is exactly two parallel light rays not exist or not there. So if you extend, they will be slightly inclined to each other. If you go on extending like this, somewhere at infinity they form like that, scientists say. So that is the reason you have to take like this, and it means that somewhere at infinity they join. That's it. So thereby you will get a image. So what do? You write the position and all. What is the position of the image? See, position of the image is at infinity. Okay, position of image is at infinity, you write. And nature of the image. What is the nature of the image? Of course, the light is really meet. So you can say real and inverted. Okay, real inverted. Okay, and the image will be generally, of course, it will be enlarged only. So you can say it as enlarged. Okay, it will appear bigger in size. So that is the reason, right? Now we'll go to the next three. One first, second is done. So 4, 5, 6 cases will go. It's very important. And sign convention rules, you know. Electricity also. Okay, once if light is done, we'll go through electricity also, and also we can go through this periodic table. Okay, so those videos also I'll upload. Now case number 3. What is the case 3? Okay, what is case 3? Case 3 is, for example, the object is kept at or between P and F you take. Sorry, this F and 2F you take. Then the light rays will go like this. Okay, and another light ray will go like this. Okay, so here the image will be formed beyond 2F. Beyond 2F. So here, so generally the image will be bigger in size than the object. So what will happen? The light. Okay, so you can say here what are the, see, generally you write like this. When object between F and 2F you take. When object between F and 2F you take. F and 2F. Okay, and where is the position of the image? Position of image will be beyond 2F. Okay, you can say it as of course enlarged, and you can say it as real inverted. Means nature means you write real inverted. Size means you would say size of the image. Size of image you would say enlarged. Okay, so this is about that. Now case 4 will do. Case 4 is, for example, you are taking the object at F. See, in this case generally the image will be of the same size as that of the object. Means when object at 2F you write. If you take like this, it will be bigger than this. Ooh. Okay, so somewhere this will be, I think, 2F. Somewhere here you take F. This is O. Okay, for example, you are taking object here. So light ray will come like this. It will go like this. So how much tall object is it? That much only it will come. Okay, here also. Okay. Okay, so like this, and the light ray which is coming from O like this, it will come from F like this. So these two light rays will meet here. Okay, this is going like this, this is going down. Okay, this is F. So this here you can say that this has 2F, and this has F. This is A dash B dash, and this is AB object. So both will be generally So you can say what is position of object means position of course at f. Position of image what at f you write. Sorry, at 2f you write. And light ray will the image will be real inverted of course, real inverted, and the size. This is nature. What is the size? Size will be generally you can take it as same size. Means size of the image will be same size as that of the object you are right. That's it. Now coming to the next step. See, this is nature of image. Nature, size of image, like that you write. Okay. Nature of image, size of image. Okay. Like that you can write. Now next one. So we have to go a little forward. That is the reason. Now 13, 4th, fifth one. Fifth one I don't think it will fit there. I think. Okay. 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 I think fifth one it won't fit. Sixth, so whatever I do, I'll love it. Students, you can pause the video and see. So fifth case, case 5. Case 5, when object beyond 2f. Beyond 2f means when you take the object beyond 2f, the image will be formed between f and okay 2f, and the image will be of course diminished. Okay. So you can take the what do you call it? Like this. These two letters will meet here. So this will be smaller. Actually, this will be smaller than the object. So you would say it as diminished. Okay. Okay. So somewhere here you can take f, somewhere 2f like that. And what about the 3 points position? I see the position of image. This is all you would write. Position of image where you would write. Position of image is the image is formed between f and 2f, and where what is the nature of image means real inverted, and what is the size of image means you have said diminished. Okay, and now we'll go to the sixth case. Sixth case is also quite important. Case 6. Okay, what do? You do this one like this. The image means when the object is at infinity. So when the object is at infinity, what will happen? This will appear to come from. Okay, means you don't need to draw any object in that case. The light rays will appear to come from. So here they will live. So generally you have to consider it as the light ray is bending and going like this, and here also the light ray is going. So these are parallel light rays. Okay, somewhere here you keep f, 2f, and this is O like that, 3 times 2f like that. When object at infinity. Okay, done. Okay, now coming to the next step, what we'll do, we'll say concave lens. Okay. So in the concave lenses, how the image is formed. Okay. See, in concave lens, image formation by a concave lens. Here, image formation by a concave lens. By a concave lens. Now what we'll do, see for example you take a concave lens. Generally at infinity, when the object is at infinity, the image will appear to come from f. So what you will do, you will take like this. So the light rays will come like this until here. Okay, the light ray will so let's see on that
19 minutes and that is it.
Stop. Okay, next video we'll see.